Welcome to Tomorrow Unveiled. Have you ever wondered if the rise of the machines is truly just science fiction, confined to the silver screen?
Right.
Well, the past week in robotics wasn't just interesting. It was a period that genuinely pushed the boundaries of what these human-like machines can do. It really suggests we're closer to that future than maybe many might think.
Indeed. Yeah, this week, specifically July 15th to 22nd, 2025, it wasn't merely about small incremental updates.
hmm
Our dedicated research team found it was really a time of strategic consolidation, some groundbreaking foundational research, and significant industrial partnerships that really accelerated the whole humanoid robotics sector.
Okay, so our mission today on Tomorrow Unveiled is to unpack the most important nuggets of knowledge, the key insights from this unprecedented acceleration.
Right.
You'll get a shortcut to being truly well-informed about what's happening, understand the why behind these breakthroughs, and maybe discover some surprising facts about how these human-like machines are already changing our world. And for me, what truly jumped off the page this week was the radical leaps in robot autonomy, specifically how close humanoids are getting to operating nonstop without, constant human babysitting.
That's a crucial point, yeah. For robots to become truly viable in industrial or commercial settings, they just can't be constantly stopping for manual recharges.
Yeah, exactly.
Energy autonomy has, well, it's always been the holy grail, hasn't it? A primary bottleneck that
Yeah.
has limited their continuous operation.
And this week, we saw a groundbreaking development directly addressing that. How is ubtech, for instance, tackling this challenge with their new robot?
Okay, so Shenzhen-based ubtech announced their new industrial humanoid, the Walker S2. And what makes it remarkable is their claim they say it's the world's first humanoid capable of autonomously swapping its own battery.
Wow, okay. Autonomously.
Yeah, imagine that the robot itself approaches a charging station, turns around, and uses its own arms to remove a depleted pack from its back,
Right.
place it into a charging slot, and then grab a fresh one. No human needed for recharging.
That's incredible.
Theoretically, this allows for true 24/7 operation.
So that sounds incredibly efficient. Is it truly seamless, though? What are the practicalities? Does it need like a special station or?
It does, yeah. It requires a dedicated swapping station.
Mhm.
But the process itself is remarkably swift. The entire battery exchange apparently takes only about 3 minutes.
3 minutes. That's fast.
Right. And it doesn't even need to power down. It uses a clever dual battery architecture that keeps it running on a backup source during the actual swap.
Oh, okay.
The Walker S2 itself, it stands 1.62 meters tall, weighs about 43 kilograms. Its battery system gives it about 2 hours of walking time, maybe 4 hours standing.
Mm-hmm.
And a full recharge for the removed battery takes about 90 minutes.
Mm-hmm.
So this fundamentally shifts the economics of deploying robots, right?
Totally.
So it turns what was a constant human-supervised chore into a fully autonomous, scalable workflow. It's really the difference between a robot being this expensive, high-maintenance machine and, well, a truly self-sufficient asset.
Right. So ubtech is tackling continuous power with these like rapid pit stops. How are other players approaching this? Is there a different philosophy emerging?
Absolutely. It's fascinating. Almost simultaneously, we saw figureai, a US-based startup, reveal their F.03 battery system for their next-gen humanoid.
Okay.
And unlike ubtech's hot swapping idea, figureai's F.03 is a 2.3 kilowatt-hour battery that's integrated directly as a structural component of the robot's torso.
A structural component. How does that work?
Well, they use high-strength stainless steel and die-cast aluminum, so the battery itself actually helps bear the robot's load,
Oh, interesting.
which saves significant weight and internal space.
So integrating it structurally, that sounds, well, ingeniously efficient. But are there trade-offs? Like, does it make repairs harder or impact flexibility?
That's a fair question. It's definitely a more complex piece of engineering, no doubt. But for figureai, it seems the benefits outweigh those potential trade-offs.
Okay.
This structural integration, they say, has allowed them to achieve a massive 94% increase in energy density compared to their first-gen battery.
94%. Wow.
Yeah. And at the same time, reducing the cost by 78% over their previous F.02 model.
That's huge.
And what's also really fascinating here is figureai's proactive push for safety certifications. UN 38.3 and UL 2271 for this F.03 pack.
Those are pretty rigorous standards, aren't they?
Extremely rigorous battery safety standards. And by pushing for them now, figureai isn't just building a battery, they're sort of aiming to set the safety bar for the entire humanoid industry. That could potentially create a regulatory advantage down the line.
That's quite a strategic move. It could genuinely influence how things develop, and they're building these batteries themselves in-house. That's a massive undertaking.
Yes, exactly. At their BotQ facility, they're targeting a production capacity of up to 12,000 humanoid units per year.
12,000.
Yeah. This focus on controlling the full stack, from materials right through to assembly, it kind of mirrors the strategy of companies like Tesla.
Right, for cost and iteration speed.
Exactly. Aiming for lower unit costs and rapid iteration. It's about optimizing for mass producibility right from day one.
So when we look at ubtech's hot swapping versus figureai's structural integration, what does this really mean for their long-term visions? It seems like two fundamentally different bets on the future.
That's a great way to frame it.
Yeah.
ubtech's hot swapping solution, it optimizes for maximum system uptime, especially in structured industrial environments like factories.
Where you can have a central swapping station.
Precisely. Their goal is continuous operation for the whole fleet, the system as a whole. figureai, on the other hand, seems to be optimizing for the individual unit cost, weight, mass producibility. Their approach suggests more of a long-term focus on a future where robots are maybe more numerous, deployed in less structured places that wouldn't have that dedicated swapping infrastructure.
Right, like out in the world more.
Possibly. It's a clear divergence in strategy, reflecting probably different target markets down the road.
This week also gave us, well, almost a masterclass in contrasting go-to-market strategies. Some companies focusing on immediate commercial deployment, others on these big public demos. What did we see from Agility Robotics, for example?
Right. On one side, you have Agility Robotics. They made a strategically very significant announcement. They signed a multi-year agreement with GXO Logistics.
GXO, one of the biggest logistics players globally.
Exactly. For the commercial deployment of their bipedal digit robot in live warehouse environments. Now, this is a landmark moment. We've been cracking this, and our research team highlighted it as the industry's first formal commercial deployment of humanoid robots, and importantly, the first under a robots as a service model, RO.
Oh, Ro. That model seems to be the real game changer here, doesn't it? It just lowers that financial barrier to entry so much.
Absolutely.
For GXO, it means these robots are an operational expense, not some massive upfront capital investment. That really democratizes access to this kind of tech. What kind of tasks are the digits actually doing?
So the initial deployment involves the digit robots moving totes, filled with goods, from autonomous mobile robots, AMRs, onto conveyors.
Okay, so relatively simple, repetitive work.
Exactly. Simple, repetitive, but highly labor-intensive. And this really demonstrates Agility's pragmatic approach.
Yeah.
They're solving a narrow but high-value problem first. Gain immediate commercial value, build that real-world experience. It's very much a proof-first strategy.
Yeah.
Focus on tangible economic value now.
Build trust in the tech.
Precisely. Build trust. Show it works safely and reliably.
And then, okay, on the complete other side of the spectrum, you have Tesla's Optimus demo.
Right.
Garnered huge viral media attention, serving popcorn at the opening of Tesla's supercharger diner in Hollywood. Quite a splash, but what was the real story there?
It certainly was a splash, yeah. I mean, from a purely technical standpoint, serving popcorn without spilling it everywhere,
Yeah.
that requires pretty fine motor control and precise motion planning. And the gestures, like waving and the thumbs up, they imply real-time vision and some human-robot interaction capabilities, which are impressive. Elon Musk framed it as this glimpse into a future where these robots are commonplace.
But there's always a but with these demos.
Well, yeah. The expert community definitely expressed some skepticism about Optimus's true level of autonomy during that demo, questioning whether it was fully autonomous or potentially teleoperated, remotely controlled, which Tesla has done in past demonstrations.
Right. I seem to recall reports maybe from inside Tesla about some internal technical hurdles with Optimus, suggesting the popcorn demo might have been more about, well, PR than immediate readiness.
You're right. Those reports, which our research team analyzed, did mention challenges, things like overheating actuators, apparently weak payload capacity in its hands, premature wear on components, and limited battery life.
Okay, so practical limitations.
Yeah. Some sources even suggested Optimus units are currently used internally just for simple tasks like moving batteries around.
Yeah.
And doing it at less than half the efficiency of human workers.
Ouch.
So while the popcorn demo was visually impressive, great marketing for sure, there appears to be a gap maybe a significant one, between that demonstration and actual production readiness.
So if we connect this back to the bigger picture, agility is taking this like proof-first approach focused on immediate commercial value now.
Right.
While Tesla is more perception-first, building a narrative, attracting talent, showing the long-term vision.
Exactly.
It really shows how this industry is maturing, doesn't it? Different companies taking very different paths to market.
Indeed. It's a bifurcation of strategy. The industry is now mature enough, it seems, to support both approaches. Tesla is betting big on a future breakthrough in general AI to make its grand vision a reality.
Down the road.
Whereas agility is betting on solving practical, narrow problems right now to gain that commercial foothold. And that GXO deployment in particular, that's a huge validation for the whole humanoid value proposition. It proves these robots can be safely and economically integrated into real operations today.
Okay, so the hardware is clearly progressing and we're seeing these different strategies play out, but it's the intelligence, the software that truly makes these machines, well, sing.
Right.
This week brought some fascinating developments in AI integration, too. Where do we even begin with the brains behind the brawn?
It did, yeah. A really pivotal announcement came from ubtech, detailing their intelligent swarm capabilities.
Swarm intelligence, okay.
Demonstrated through a large-scale practical training program at a ZE car electric vehicle factory. So this isn't just about controlling one robot anymore, but orchestrating a whole collaborative fleet.
Right.
And at the heart of it is their BrainNet architecture.
Tell us more about BrainNet. How does it actually enable this multi-robot collaboration? What does it look like in action?
Okay, so imagine BrainNet as kind of a two-tiered command center. You've got the super brain up in the cloud.
Yeah.
This is powered by a sophisticated, large reasoning, multimodal model.
Multimodal meaning.
It can process lots of different types of information, visual, textual, sensor data. Think of it like the conductor of an orchestra.
Okay.
It makes the high-level strategic decisions, breaks down complex production goals, and assigns them to the robot fleet. ubtech actually claims to have developed the world's first such model specifically for humanoid robots to serve as this superbrain.
Wow.
And then below that, each robot has an intelligent subbrain. That's its onboard AI. It translates those high-level strategies into immediate actions, reacts to its local environment, controls its precise movements.
Gotcha.
And this whole system connects through what ubtech calls the Internet of Humanoids, or IOH. Just enables seamless data flow and coordination between them all.
What's really fascinating here is how general AI models, these big, powerful models, are being adapted to give robots more, cognitive abilities, moving beyond just following commands to truly understanding and collaborating.
Exactly. That's the key leap. This enables true multi-agent collaboration. Robots can self-organize, they can dynamically reallocate tasks if one fails, or, like we discussed, needs a battery swap.
Right.
They can even coordinate to move large or heavy objects together, sharing perception data. It means moving from simply automating a task to automating an entire workflow.
Which is critical for future factories.
Absolutely critical. And beyond that, this week also saw some interesting algorithmic advances from academic research their team flagged.
Oh, yeah.
One paper looked at learning robust motion skills via critical adversarial attacks. Basically, using an adversarial training method to bridge that tricky sim-to-real gap.
Sim-to-real, making what works in simulation actually work in the messy real world.
Precisely. It trains the robot to anticipate and withstand challenges, making it tougher, more reliable in unpredictable environments. It's essentially battle-hardening the robot's movements in simulation before it even takes a step.
That sounds incredibly smart for real-world reliability.
Doesn't it? And another interesting piece of research was called Robot Drummer, learning rhythmic skills for humanoid drumming.
Robot drummer? Seriously?
Yeah. It showcases how AI is enabling complex, long-horizon, and even expressive physical abilities in robots, moving beyond purely utilitarian tasks towards, well, creative expression and precise timing.
Huh. So it hints at a future where robots might not just be factory workers, but maybe performers, artists.
Potentially. It shows the dexterity and control AI is enabling. And the broader trend underpinning a lot of this is the integration of large language models, LLMs, and vision language models, VLMs, from the big tech giants into robotics.
Like the AI behind things like ChatGPT, but for robots.
Kind of, yeah. For example, Google DeepMind's Gemini Robotics on-device model lets a robot understand natural language commands, and it can be fine-tuned for new, complex tasks with just minimal demonstrations.
And we're seeing this play out in actual industry partnerships too, right? Companies leveraging these advanced AI platforms.
That's correct. We saw Hexagon's new Aeon Humanoid is built entirely on NVIDIA's robotics stack, using Isaacsim for training, Jetson Orin computers for the onboard AI,
Okay.
and Aptronic announced a partnership with Google for AI, leveraging their Gemini 2.0 models.
Right.
So it really illustrates this kind of bifurcation again. Some companies, like Tesla and figureai, are building these full-stack proprietary systems trying to own everything,
Hmm.
while others, like Hexagon and Aptronic, are taking a more modular approach, plugging into external AI platforms. The long-term success of each strategy, well, that's going to be a key competitive dynamic to watch.
Definitely.
Yeah.
Now, it's important to acknowledge that while humanoids are certainly the stars of our deep dive this week, other robotics fields are also making incredible strides. It helps to put the humanoid progress in context.
Indeed. Yeah, our research team found several significant non-humanoid advancements just this week that are worth noting.
Yeah.
Amazon, for example.
Ah, the logistics giant.
They announced the deployment of their 1 millionth warehouse robot.
1 million. That's staggering.
It is. And maybe more importantly, they're using a new generative AI model called DeepFleet to optimize the travel paths of their entire fleet. They claim it's already improved efficiency by 10%.
Okay, so that sets a really high bar for humanoids trying to break into logistics, showing what's possible with simpler, specialized robot fleets at huge scale.
Exactly. It shows the level of optimization they need to compete with.
And speaking of companies we've mentioned, we also heard about Tesla's robotaxi launch. A bit quiet, wasn't it?
Yes, very quiet. Tesla launched a limited employee-only robotaxi service in Austin, Texas, crucially with no human safety driver on board.
No safety driver. That's a big step.
It is. And it's significant because the core AI stack powering those autonomous vehicles is essentially the same technology intended to give the Optimus robot its physical autonomy.
Ah, so the performance of the robotaxis is a direct indicator of the AI maturity for Optimus.
Pretty much, yeah. How well those cars navigate. Austin will tell us a lot about the AI that will eventually, hopefully, power Optimus. We also saw a Chinese quadruped robot, the Black Panther's second, breaking speed records.
Like Boston Dynamics spot, but faster.
Apparently. Sprinting 100 meters in just over 13 seconds. And beyond that, consistent advances in specialized robots for agriculture, defense, even healthcare. There was a Canadian robot reported that can autonomously draw on blood, minimizing human contact.
Wow. Okay, so this really raises the big question. What does all this rapid progress actually mean for us, for society, for the economy? These aren't just technical curiosities anymore, are they?
No, not at all. The humanoid market is clearly fragmenting strategically. With companies specializing, you've got Agility focusing hard on logistics, ubtech on industrial manufacturing, Hexagon targeting inspection. This specialization itself is a hallmark of a maturing market. It indicates real-world demand is starting to pull the technology forward.
And the economic impact. The projections are often huge.
They are. There's definitely an optimistic view that humanoids will address critical labor shortages, think elder care, dangerous jobs, and significantly boost productivity overall. Morgan Stanley, for instance, projects a, frankly, staggering $4.7 trillion annual market by 2050.
4.7 trillion. But
Yeah.
there are also concerns, aren't there? The conversation around potential job displacement always comes up.
Absolutely, and rightly so. Some experts do warn of significant job displacement if robots become capable across many domains. Some even use terms like an extinction-level event for certain occupations.
Strong words.
Very. However, many economists take a more moderate stance. They suggest humans will likely remain essential for complex judgment, creativity, empathy-intensive roles, things robots aren't good at, or maybe never will be. History does show technology often creates new jobs, even as it replaces old ones. But the speed of AI robotics advancement this time feels different. Society will need to adapt through retraining programs, maybe new economic models, at an unprecedented pace.
What are the other big hurdles for widespread adoption beyond those economic shifts?
Well, scalability and cost are still major ones. Mass manufacturing these complex humanoids is really hard, and the unit costs need to fall significantly to compete with human labor on a large scale. Aptronic, for example, has a stated goal of getting under $50,000 per robot.
Still way to go, likely.
Probably. Safety and robustness are absolutely paramount, especially as these robots move out of controlled factories and into more unstructured environments working alongside people.
Can't have them tripping over the cat.
Exactly. And finally, public acceptance and integration. Managing workforce transitions smoothly. Managing public perception. That's going to be key as robots move from the factory floor into more public-facing roles. It's a really crucial balance between the tech capability and societal readiness.
And all of this is happening within a broader geopolitical context, isn't it? Which just adds another layer of complexity to this whole rise of the machines narrative.
Absolutely.
Yeah.
The U.S.-China tech rivalry in AI and robotics is, well, it's a central pillar of global technological competition right now.
Right.
China's strategic industrial policies, like Made in China 2025, have heavily supported their domestic champions like ubtech. And the sheer scale of their domestic market provides just an unparalleled environment for deployment and iteration.
Learning opportunities at massive scale.
Exactly. So the breakthroughs we've talked about this week, they're not just technical achievements in isolation. As our research team noted, they are effectively moves on a global chessboard. They're shaping not just our technological future, but geopolitical power dynamics as well.
So, the rise of the machines, it really isn't just a technical achievement anymore. It's become this global conversation about our collective future. What we've seen this week, I mean, from autonomous battery swaps and landmark commercial deployments to sophisticated AI swarm intelligence and these bold moves by global tech giants, it really confirms that humanoid robots are rapidly transitioning from, research curiosity to practical reality. It certainly gives you something to think about, doesn't it?
It really does. Consider this. If these trends continue at this pace, how will your daily life and your work environment change in just the next 5 to 10 years? What tasks might you be doing alongside a humanoid robot? Or what completely new industries might emerge that we can't even imagine today?
It's fascinating stuff. If you're finding this insightful here on Tomorrow Unveiled, please take just a moment to like this video, subscribe to Tomorrow Unveiled, and definitely turn on notifications so you never miss an update on the future we're exploring.
And if you're listening on a podcast service like Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and review for Tomorrow Unveiled. It genuinely helps us reach new listeners who are curious about these topics.
We really love hearing your thoughts too, so whether you're on YouTube or your favorite podcast app, please leave a comment and let us know what you think about this rise of the machines in robotics.
Thank you for joining us on Tomorrow Unveiled.
We'll be back next time with another deep dive into the fascinating world shaping our future.